Do you remember what was special about the picture? The ripples. Good. And the ripples, like waves. Oh wait, what else comes in waves besides water? Or happens?
Sound.
Right, light, sound.
Radio, electric.
Yeah, we go to like radio waves and electricity and things like that. We go into like heartbeats and how we see with heartbeats on a monitor. It seems to have somewhat of a wave-like pattern. It's a bit more extreme though. Yeah, radiation. So we talked about how a lot of nature behaves in wave-like, we'll just say waves, but have like wave-like movement. And then we talked about how you guys had your calculators out, we were in radians, we were in degrees. People in degree mode wasn't showing up so good unless you went into what, Zoom? Zoom, not standard. Trig. Degree only worked in Zoom Trig, because we had to like get that negative 360 to 360. We had to totally expand that x-axis, but the y stayed little. But which mode worked well in Zoom Standard? Not degree. Radians, because radians are a lot smaller. Negative 6.28, 6.28. Okay, so then we figured out with our calculators, if you're in degree mode, it might look really funny unless you do Zoom Trig. If you're in radian, Zoom Standard is good. But we saw that waves appear when we use sine or cosine. And ironically, I guess in our class we didn't fill in the name for the shape of the graph. The graphs are called sinusoids. The graphs are called sinusoids. But we could say that the graph is, if you're thinking about an adjective, okay, English people, my grammarians, we can call them sinusoidal curves. Sinusoidal curves. But just think of it as trying to pattern waves, trying to model waves. So sinusoids, they're sinusoidal curves, and we just started talking about one basic cycle of sine variance and one basic, they were very worried. Did you get lost though?
No.
Okay. Talk to me after real quick. Cosine also has a wave-like pattern, but it has a different cycle than sine. Now the weird thing is, kiddos, if I was to, let me zoom in on the second page. You guys hopefully got down sinusoids, right? Here, everybody say it real quick, so it's just a fun word. Sinusoid.
Sinusoid.
Or say sinusoidal.
Sinusoidal.
You kind of sound like you're from New York, right?
New Jersey.
Yeah, New Jersey? There you go, that works too. Okay, so, this second page. Question. Do sine and cosine have the exact same shape?
No.
Okay, true or false? Sine and cosine have the exact same shape.
Well, they have different
A lot of people would say false.
No, it's true, because they do it.
So what if I was to
Yeah, see?
put them together?
Bam.
They are the same shape, good, but they start at different places. Sine starts in the center at equilibrium.
Amen.
Cosine starts at the top. Now I know it's going to be kind of hard for you guys to visualize, but if I was to, let's see. Okay, do you guys ever play the game, probably elementary, maybe it's in like Awanas or something if you were in Awanas at church. The game where you have a big old parachute, and then they throw like balls in the middle.
Oh,
The video like you getting sucked in. Great game. Or you have to like run under and then, anyway, but the balls are kind of fun, so you have to keep on the sheet. Okay, if you are, or like if you ever helped your mom like fold sheets, right, and then you're like, ha ha ha, and then you just like rip it out of her hands, it's awful. Anyway.
wow, that's mean.
Okay, it is neat. Let's say that you have the parachute or you have a sheet, okay? Sine starts here in the center, and then it waves up, and then down, and then back up. Sine starts in the center, so you would be holding the sheet, and then you would flip up, and then it's going to, by default, go down and then back up again to equilibrium, okay? Cosine, you start at the top, and you throw it down. Does that make sense? As you throw it down, that's going to come back up. So cosine starts at the top, it goes down and back up. Sine starts in the middle and then pushes up and then comes back down and it's back to equilibrium. So they start in different places, but it's the exact same shape, and I could overlay them if I had done this perfectly, and it should match. So same shape, sinusoid curves. Now, what was the one transformation that we looked at on Friday to a sine or cosine? This one's a sine. What's this 2 do? Not a shift, it's not plus, it's times. It's not a shrink because it's on the outside times 2, stretch. Vertical stretch by a factor of 2. So what do you guys notice about the sine curve? What happens to the height of the sine curve? Instead of going up to 1, where did it go up to? And instead of going down to -1, where did it go down to? Okay, So the entire thing got stretched by a factor of 2. Its highest point, its amplitude up 1, is now up 2. So the height from the equilibrium, how high it goes is 2, and how low it goes from equilibrium is also 2, but in the negative direction. Can you guys look at your beginning sine curve? Did the horizontal distance it takes to complete, aka the period, did that change at all? Look at your original sine curve. Was it 2 pi? Okay, so did the horizontal measurement change at all? No. The only thing that changed was the vertical displacement from equilibrium. So vertical stretch, all we did is stretch it. No big deal, right? We can do that by hand without hopefully stressing out too much, but the problem is, can other transformations occur to a sine or cosine? And the answer is yes. Vertical transformations, vertical dilations, vertical stretches and shrinks are only one of many that can occur. Only one of many that can occur. The difference between these two, there's only one little baby difference. This one has a number multiplied into the argument if there is a horizontal dilation. This one has the horizontal dilation factored out. So the top form has the dilation factored in or multiplied in to the argument of sine or cosine, and the bottom one has it factored out. To be honest, of all of these, probably the ones that we're going to look at most are going to be the bottom two. But I do want you guys to realize that you can take something written in the top form and you can make it into the bottom form just by factoring out. But here's the deal. Sine and cosine, they're kind of complicated enough without getting or putting in all these different transformations that can occur. So therefore, I kind of have a system to analyze each of these different transformations by name, because they're waves. They're not just math, like lines or parabolas with domains and ranges. They're waves that occur in nature. So I'm going to use some terminology about waves to kind of describe what's going on with all these different changes. And if we can properly analyze them all first, we should be able to go straight to the final transformed wave, sinusoid, without having to do each transformation one by one. We should be able to take them all after we've analyzed them and use them to go straight to the final graph. Because if you guys remember before, when there were lots of transformations, you kind of had to do one transformation by shifting this direction, do another transformation by then shifting that direction, do another transformation by then stretching, and another one by flipping. Do that with a sine or cosine would just be awful. So let me go ahead and give you some of these clue words that we're going to go ahead and try to use to help us work with these waves. D, mathematically speaking, is called the sinusoidal, and that's a great word, axis. The sinusoidal axis this is the same thing as equilibrium, meaning if the water was perfectly still. Meaning if the water was perfectly still. Sinusoidal axis at y equals d, meaning if the water was perfectly still, the wave hasn't gone up or down. Another way of thinking about it is you could think about it as the middle. The water is perfectly still, or the middle of the oscillating wave. A is for amplitude. A is for amplitude. Which we could think of as the height of the wave. How high does it go? And that's not a y value. Instead, that's more of a distance. And we'll try to show that on a sketch in just 1 second. Amplitude, how high the wave goes, which similarly will also be how low it goes, how far up it goes, and how far down it goes. B is a little hard. Let's skip him for just a second. Because B you can't actually see outright on a graph. It's more used to get something on the graph for the wave. But C over B is a little bit easier. C over B is going to be the initial point. And it's indicative of an x value, which we can kind of tell because it's in with the x's, whereas D is out with the y's. So D is a y value. C over B is an x value. And it's the initial point. It's where the wave starts. So, quick reminder. If we have sine, initial is at y equals d. It's going to be at the middle. It's going to be at the equilibrium. You start from the middle, and then you have, or you flick the sheet up to get the height, and then it comes back down for the how low it goes. Sine is going to start at y equals d. Cosine, unless it gets flipped, is going to have its initial point at y equals d plus a. Cosine starts at the top, starts at d plus how high it goes, and then it flips down and then goes through its cycle. Sine's going to start at d, cosine's going to start at y equals d plus a. That's the words. And for some of you, words are enough, but for a lot of you, we need to get a picture to kind of try to put it all together. Yeah? So quick picture for our sines and cosines. We could say, sine, remember, starts in the middle and then it goes up. Back to the middle, goes down, back to the middle. Cosine, remember, starts at the highest, comes down through equilibrium, down to the lowest point of the wave, and then comes back up. So sine's initial point is right there, cosine's initial point is right there. Sine starts in the middle, cosine starts at the top. Now technically, I do have like a lot of words to go ahead and describe some of these in a bit more detail, but guys, didn't we miss one? What have we not written about yet? Ooh. Okay, so A, multiply on the outside of sine or cosine, that vertically stretches or shrinks. What's B going to be if you're multiplying on the inside or with the x value? Yeah, it has to do with the length because it's technically mathematically a horizontal shrink or stretch, right? But do you remember when there's a transformation on the inside or on the argument of a function? Remember this minus? Isn't it backwards what I think? So for adding or subtracting, we're moving to the, if it's backwards what we think. If we're subtracting on the inside, which way are we shifting? To the right. And if it's adding, we're shifting to the left. So what's happening if B is some sort of whole number? Is it going to be shrinking or stretching? If there was like a 2 right here. If there's a 2 on the outside, it'd be stretching. If there's a 2 on the inside, shrinking. Because remember, B, horizontal dilation, is always going to be actually multiplying by 1 over. Horizontal. When we come to stretching and shrinking, we always have to take whatever is being multiplied on the inside and think about its reciprocal. So B is going to take the length of a curve, which is called its period. The normal period of sine and cosine is 2 pi. Another way of looking at it is you could put 2 pi over B. And that's how we're going to find the period, which is the length of one cycle. How long it takes to get one cycle. So B, it doesn't actually go straight to the graph at all. Instead, it's a formula. So I'm going to box this one because he's the one weird one. B doesn't go straight into the graph. We use B, we actually use 1 over B times the old period or the normal period, the non-transformed period, to figure out how long one cycle will be now. Or how much length it will take to go ahead and complete. Okay, now we can go into lots of words, but I actually just want to give us an example. So let me go steal an example real fast so we can actually put all this to work. I think I have one. Let's find a nasty one. How about this one? Let's do this one. Alright guys, go ahead and write down this equation. It's kind of nasty. There's a lot that's been done to it. I want you guys to look at the equations that you just wrote. Question, has the b been multiplied in, or has it been pulled out? Which equation does it look like? Yeah, it's been multiplied in, so it looks like the top one where we have bx plus c. So I'm going to go ahead and rewrite this really quickly because we like it better if we pull the b out. So there's the b, whatever number is being multiplied by the x. I'm going to rewrite this just a little bit. I want you guys to see and double check if you agree with how I rewrote it. So y is equal to 0 minus 3. Wait, why did I put a 0 there? If you guys look at your formula, what am I trying to show you in that spot? Good, I'm trying to show you d. So if there's nothing being added or subtracted outside, the cosine, this is being multiplied, the negative 3 is being multiplied, but if there's nothing else, then the d must be 0. AKA there's no vertical shift at all. So my d is 0. My minus 3 must have something to do with amplitude. I pulled the b, the number being multiplied by x, I pulled the b out. So now I can go ahead and label everything. I have d, I have a, I have b, and this must be c over b. That works. Alright, let me show you how to put all this into a graph. But before we go into a graph, hold on. There is one formula I need to plug into. What's the one guy up here that I can't actually say is exactly a characteristic of a graph yet? What's the one guy that needs to be plugged into a formula? Yeah, the box that we made, B, right? So what's that formula for B? How do I use him? Period equals? Yeah, you can say 2 pi over b. That's one way of putting it. Another way of putting it is you could also say 1 over b times 2 pi. But what happens either way, guys? Whether you do 2 pi over b or 1 over b times 2 pi, both of these will become just 1. Okay. So I have that my d, or my sinusoidal axis, is 0. My a, my amplitude, is 3. I have that my period is 1. And I have my c over b is actually negative 2. So I have my d, my a, my period, and my c over b. Do you guys remember when you were, we were talking about this just a second ago. Nikki brought this up, and randomly it's going to apply. What letter did you forget when you first joined 2nd grade? Mm-hmm. Do you guys remember what you had to do when you first started learning letters? How did you first start learning letters?
Write them out loud.
Write them out a lot. What kind of special paper did you use? Come on, you guys.
Oh, those rounds.
Yeah, right? Where you have like the different, you do different colors, different dashes. You have the one in the middle, and then you have like the upper and lower. Right? And then like for the letters, they had like the little light ones. You had to actually like go over them, and then you got to like try on your own the uppercase,
I was
lowercase.
very embarrassed. So I don't know how to write.
My hand's ringing. Is it cursive?
No, it was regular. I was like,
It's a good thing. You only need like the A's and B's and C's.
yeah.
Okay,
Coming
coming back. We're going to make handwriting lines for our waves. Because waves, unless we have like gravity and forces acting on it, we're just like in a vacuum right now, the wave will just go on forever. Waves, sines and cosines, are just going to stay at the exact same highs and lows. So we need to go ahead and make some handwriting lines to go ahead and put those waves in. Ready? First, we need the middle line. The middle line is, wait, what did we say was the middle? Did we write the word middle somewhere?
No.
Oh, yeah, we did. Underneath equilibrium. Maybe you didn't write it. I did. Middle. Yeah, sinusoidal axis. So who's that? 0. Ready? At y equals 0, our sinusoidal axis. I'm going to draw a dotted line, the middle of our handwriting lines. So we can say SA, the sinusoidal axis, is going to be at y equals 0 for this one. Amplitude is going to equal 3, not negative 3. We'll deal with the negative in just a second. Ooh, that's a reflection. It's okay. So that means that we're going to go up 1, 2, 3, and we're going to go down 1, 2, 3. And guess what? going up and down, the highest that the wave can go and the lowest the wave can go, that gets us our upper bound. And our lower bound. You guys see the handwriting lines? You could make it solid if you want. I do a dash just to keep it separate from the graph that I'm going to show in just a second. You could do it solid, I suppose. I keep it dashed to keep it separate from the graph that I'm going to make solid in just a second. So if I do sinusoidal axis, where's the center? Amplitude, I counted up 3 from the center, down 3 from the center, or from the equilibrium. I'm halfway there. I'm actually going to do next my initial point. Is going to be at, sorry, not equals. Now, we know the x from what's been given right here. The x is going to be -2 because right here in the c over b spot we have +2 and the formula says minus c over b, so minus a negative. So -2 is the x on stink-a-dink, but I still need that. Help me out. Do I have sine or cosine? Okay, look at your formulas. What did I say about the initial point of a cosine? Yeah, it's going to be d plus a, right? Normally for a cosine, since it needs to start at the, can I go ahead and show you the handwriting lines real quick? There's the sinusoidal axis, there's the upper bound, there's the lower bound. For cosine, I'm going to say, hey, y equals d is the center. I need to count up a to get to the top. So d plus a, I get the top. For sine, didn't I say that starts just at d? Because sine's going to start at d. So normally, for the y value, we could just say, hey, d plus a is going to get us cosine, whereas just d is going to get us sine. But question, why am I actually going to say -3? D plus a on this one, isn't that? Oh. Why is this one starting down and not up? It's a reflection. There's a negative outside the cosine, which means normally the cosine waves start up, but this time I'm starting down and flipping up. Okay? So in this one, we need our cosine to start at -2, -3. So we're going to have it actually start, because of this little negative, my cosine is going to be going this way instead. Does that make sense, guys? The cosine has been flipped. So instead of starting at d plus a, it's actually d minus a, which is really what you see right here in just the equation. All right, now the struggle is we don't want to go marking any tick marks until we figure out what we should be measuring by. So let's go ahead and get our period, which we already solved for. The period is 1. I need you guys to write one more thing. Every sine and cosine curve can be split up into 4 pieces. 5 points, but 4 pieces. If you guys look at this cosine, we have a bottom, a middle, a top, a middle, and a bottom. But how many sections do we have? 1, 2, 3, 4. If I was to mark this on like a little baby number line, I was to actually have it be the beginning and end of my curve. If I put in those 5 different key points, all right, my people that are talking nonstop, shush. If I put in those 5 key points, do you see how I've cut this into 1, 2, 3, and 4 into fourths? So question, if I go by fourths, I'm going to need to make sure the tick marks on my x-axis measure up with quarters of my period, so 1/4. So here's how that makes a big difference. If I was just to look at my initial point, and if I was to say like, oh, no big deal, there's -1, there's -2. Yay, let's put our point. What does this tell me I need to do now? After 1, I need to have done my entire cycle. So I guess I could go ahead and cut this little baby down into fourths. And I could go top. I can actually get this oriented. But how clear is this? hopefully it's clear, but it's kind of messy. If we were to go instead of by -1 and -2, if we were to change and say, wait a minute, quarter cycles, let's go by a fourths. Couldn't I then go ahead and say, okay, -1/4, -1/2, -3/4, -1, -1/4, -1/2, -3/4, -2? Couldn't I then come back and say, okay, -2, -3? And couldn't I then say, let's go over a fourth, and I'm going to be at the middle. Let's go over a fourth, and I'm going to be at the top. Let's go over a fourth, and then be back to the middle. Let's go over a fourth, I'll be down. Because of the way that I put the tick marks on my horizontal axis, now I can clearly show my wave just a little bit better. Now, in reality, aren't I really zoomed in right now?
Yep.
That's -2. I'm really zoomed in, so maybe it is nice to have the little baby tick marks and put a little squish curve in for you to realize what's going on. But as far as nicely showing the curve, sometimes taking a quarter of the period helps us know how to put our tick marks. So if I wanted to keep going, if they wanted more than just one cycle, if they wanted me to even get on the positive side, I could keep going. All I need to do is just keep going over a fourth, and I'm just going to keep cycling as long as they want. Sometimes they tell you do like 2 cycles, sometimes they tell you show it from -pi to 3pi. This one will just say we have 2 cycles, little arrows say, yeah, it's going to keep on bouncing, you could keep on doing it if you wanted, but as long as you have about 2 cycles, you should be good. So what we did is we analyzed all these characteristics first. We made our handwriting lines. Where's equilibrium? Where's the highest the wave can go? The lowest the wave can go? Where's the wave going to start? At -2, -3. What are my tick marks in order to make the rest of my cycle? Good. Instead of necessarily having to think about, ooh, what's the shift horizontally and vertically, and let's put that together with the shrink or the stretch horizontally and vertically. If we can just think of in terms of all these different characteristics, we'll be able to hopefully put them all together to get our curve. So, really quickly, just a couple more ways of looking at the words. And maybe you don't need to write all this because we've already kind of talked about it. But if it does help, amplitude. Quick reminder, amplitude, how high, how low? It's half the distance from the very top to the very bottom. It's half the distance. I'll just use sine as an example. Amplitude measures up from the sinusoidal axis and down. So if you were to go from the very max to the very min, it's going to be 2 amplitudes. So amplitude, how high up and how low down. Amplitude, how high up and how low down. Here's another thing about amplitude. Amplitude is always positive. If you get a negative in there, you're going to have a reflection. But amplitude itself is always positive, just a measurement. Oh, one little blank notes. Keep going. Period, how long or how far? The horizontal distance from the beginning to end of one cycle. I think we kind of wrote that. We didn't give all the words. If you want the words, there they are. Amplitude, always positive, half the distance from the very top to the very bottom. That's more like a physics way of talking about it. It's got shifted somehow. Translations, we can have vertical shifts, and that's going to be seen with our sinusoidal axis. Horizontal shifts are going to be seen with our initial point. I can spell initial. So if for any reason, if your sinusoidal axis is 0, there is no vertical shift. If or your C over B is not there, if there is no plus or minus on the inside, there is no horizontal shift. It'll just start like normal. But a snazzy name for this horizontal shift, that's why it was shifted. A snazzy name for the horizontal shift is a phase shift. Another way of talking about waves, instead of talking about cycles and periods, you can also talk about phases. You can talk about phases of the moon if you want. Waxing and waning. But with the phase shift, that's another snazzy name, just in case it ever comes up, that you guys know the initial point is the same thing as the phase shift. I just want to tie that vocab in for you, just in case it shows up in any point. And with that, let's try to get to know the graph before we finish. I'm going to move this page. This is a summary page. Maybe that'd be a good thing for us to look at. At the end of tomorrow. I do have some homework helps. We probably won't get to all of them, but I want to get to at least a couple. That one's a little easier than I think we really need. Let's skip to this guy. Let's skip to this guy. Now guys, we have talked about some of this vocab. Just getting a little more technical about amplitude, a little more technical. Phase shift is like the initial point. I was talking about a lot of things kind of mathematically, but tying them into how physics would kind of refer to them. But let me go ahead and grab my little clue page from back up here where it went through all of our different transformations. Let me bring him down to where we have another nasty example. I want you guys to help me label stuff. So if you just go in order, let's see, the first thing that we should talk about is our SA, then our amplitude. I think the next thing was our initial point that we just learned is also called a phase shift. What's the last one? There are 4 things. Sizeable axis, amplitude, initial point, and period. Good. Okay, who can fill in something? What's our sinusoidal axis? Where's he coming? Good, -3. So that's our SA. What's our amplitude? That's how high it's going to go. How high or how low. Ooh. What's our initial? Can you guys tell? This one's written weird. I know, it's kind of written weird. Maybe we should rewrite it a little bit. Maybe we should rewrite it to be. Let's see if this helps. -3 plus 5 cosine of. What would I factor away? What's being multiplied by t? Can you guys tell? T is like our x. Let me write him there. What's being multiplied by him? Pi, but not just pi. Can you see it? It's pi over 12. It's pi over 12, which in essence is going to need to be put down here, and that's our b, which another way of doing that is 12 over pi. We'll get to that in just a second, but we need to go ahead and do 1 over b. Pi over 12 is our b. So question, if that's the b, then what's my c over b? Josh, what do you think? Let's see if other Josh can help. What do you think? What else is left? Can anybody help? Who's c over b if we've already written everybody down? Careful, but he's in our B spot, right? We'll struggle. Who's this guy if there's nothing left? Nothing. Exactly. It's just 0. But see, if we rewrite it, can't we see it a little bit better? There's nothing left. Okay, fine. -0. So then who is C over B?
0.
So how am I going to fill in that Y? Who is this? Sine or cosine? It's a cosine. So where's he going to start? Y equals D plus A. So then what's D plus A? D is -3, right? plus 5 is 2. And then if we just go ahead and simplify this real quick, the pi's cancel out. We have 24 as our period. And if we were to do quarter cycles, that helps us know how to separate or split up our graph. That's going to be 1/4 of 24, which is every 6. All right, let's see if we can put it together. Handwriting lines. Where's my middle going to go? We gotta make our handwriting lines. Where's the middle? Who is that? Good, -3, the very first one. So we're going to go down to -3 and throwing things. Struggle, huh? Hey, where's -3? Come on, cool kids. Some of you have already done it. Some of you, it seems a little off. Why am I doing the middle line at -3? Because that's my sinusoidal axis. How high does my wave go? What's the upper bound of my handwriting lines? Yeah, it's going to go up to y equals 2. And then Ryan just, I think that was you, right? Good, -8. So I have to add 5 to -3, subtract 5, so I end up with my upper bounds. I end up with my lower bounds. My initial point is going to be at 0, 2, so I can go 0, 2. Because on the axis, I don't have to worry about my tick marks yet. So I can go ahead and mark that. There's no like vertical flip, so it's just going to start at the top. What am I going to make my tick marks on my x-axis? My y's are just by 1s. That's 2, that's -3, that's -8. But what are the tick marks on my x-axis? We could go by 2s if you want. We could also just go by 6. It's up to you. If we do go by 6s, even if you go by 2s, every 6, you're going to have to go ahead and get another key point. So cosine starts at the top. Where's it going to go? Follow the flow. Where's it going to go if it's at the top? Back down to the middle. Careful, not the x-axis. The sinusoidal. Then where's it going to go? Follow the flow. Down to the bottom of the wave. Follow the flow. Where's it go next? Back up to the sinusoidal, not the x-axis. And then where? Imagine there was a drought and the water level dropped. It can't go to somewhere where it's not. Then what are you going to do? Alright, kiddos. Tonight in homework, I want you guys to basically fully attempt it. We'll say it's due tomorrow, but we might go ahead and look at the very end types of homework problems, and I'll put one up here just for you guys to see as you leave, where it gives you a graph in the 70s and says to make an equation. You might not be ready for that, but you are ready to sketch. So get up to like the 70s, and that would be pretty good. Bye, kids. See you later. If you have correction questions, come on in.
Yeah, how about that? You're doing way well? Oh, yeah. Oh, yeah, you're doing straight.
That's crazy. For this one, it's mostly because I didn't know how much sleep I was going to need. So, because I saw a lot of problems